Good morning, students. Yesterday we discussed about mean and variance of discrete random variable. Next we have mean and variance for continuous random variable. So the mean expectation of x, which is denoted with mu, and it is defined by integration from minus infinity to infinity x into f of x dx for continuous random variable. The variance v of x is defined by sigma square, and it is defined as integration from minus infinity to infinity x minus mu whole square into f of x dx, which can be written as integration from minus infinity to infinity x square f of dx minus mu square plus the product term vanishes here, that is equal to, you can write in terms of mean, that is expectation of x square minus expectation of x whole square. The standard deviation is square root of variance, that is sigma. Let's see problems on continuous random variable. A continuous random variable it has a probability density function f of x equal to k, which lies between x lies between 0 and 1. We need to determine the constant k and the probability value. To calculate the constant value k, we know that the total probability is 1. So here the probability density function is f of x. So integration from minus infinity to infinity f of x dx equal to 1. But the functional value is defined in the interval 0 to 1. So we will restrict minus infinity to infinity as 0 to 1. So the limits are 0 to 1. Functional value k dx. Equate that one to 1. K common, integration of 1 x within the limit 0 to 1. So k into 1, that is 1. So k value is 1. Now we need to find the probability value, that is x less than or equal to 1 by 4. So we need to take the integration from minus infinity to 1 by 4 only. Integration from minus infinity to 1 by 4 f of x dx. Here minus infinity we are replacing with 0 because the function is well defined in the interval 0 to 1. So starts from 0 here, 0 to 1 by 4. F of x is 1 dx. Integrate that value. Integration of 1 is x. So within the limit 0 to 1 by 4. So your probability value is 1 by 4. Now given that the probability density function of a random variable capital X is f of x equal to kx, within the limits x limits 0 to 1, x less than 1, find k and probability value, that is x greater than 0.5. So to find the value of k, you know that total probability is 1. So we need to take from minus infinity to infinity f of x dx as 1. But the function is defined in the interval 0 to 1. So that implies 0 to 1, integration 0 to 1 f of x dx equal to 1. That implies integration from 0 to 1 f of x functional value is kx. dx. By integrating and substituting upper limit minus lower limit and equating that one to 1, you'll get the value of k. The k value is 2. Substitute the k value in function f of x equal to kx equal to 2x. F of x is 2x. Now we need to find the probability value, that is probability of x greater than 0.5. So start your integration from 0.5 itself. The remaining value is 0 here. So integration from 0.5 to infinity f of x dx equal to integration 0.5 to 1, because the function is defined up to 1 only, 0 to 1. So 0 to 1 to x dx, remaining values are zeros. So that is equal to 2 into x square by 2. 2 to cancel, substitute upper limit minus lower limit. Which is equal to 3 by 4. Let's solve one more problem. For the continuous probability function f of x equal to k x square e power minus x, for x greater than or equal to 0, find k, mean and variance. So to find the value of k, we know the total probability is 1. That is from minus infinity to infinity f of x dx equal to 1. The function is defined for x greater than or equal to 0. So you can write the integral value from 0 to infinity. Function is kx square e power minus x dx equal to 1. That is equal to, in the function you have added two functions x square and e power minus x. Integration by parts. Apply Eilert rule. Equate that one to 1. Simplify it. Substitute upper limit minus lower limit. You can observe that the value of k is 1 by 2. Here you need to apply integration by parts to simplify this one. You can apply or you can solve in your own way for integration by parts. Now coming to mean. Mean is defined as mu equal to expectation of x equal to integration from minus infinity to infinity x into f of x dx. Substituting the values, since x greater than or equal to 0, integration starts from 0. So limits integration 0 to infinity x k x square e power minus x dx. Again here you have two functions x cube and e power minus x. Again integration by parts. Substitute upper limit minus lower limit as 0. Substitute the k value as 1 by 2. So 1 by 26, that is 3. So mean is 3. Now to calculate variance, formula for variance is variance of x equal to sigma square equal to expectation of x square minus expectation of x whole square. So first calculate expectation of x square. Formula integration from minus infinity to infinity x square f of x. X square f of x. F of x is k x e power minus x. K value 1 by 2. So 1 by 2 k you can take right outside. You'll get x cube into e power minus x inside. X cube into e power minus x inside. Simplify the function within the limit 0 to infinity. Your expectation of x square value is 12. Now variance of x equal to expectation of x square minus expectation of x whole square. So 12 minus 3 square. That is 12 minus 9, which is 3. Now coming to the next problem. If x is a continuous random variable with distribution function f of x equal to x by 6 plus k for x lies between 0 and 3, otherwise the functional value is 0. We need to determine the value of k, mean and probability value of x which lies between 1 and 2. Now to find the value of k, we know that the total probability is 1. So integration from minus infinity to infinity f of x dx is 1. But the function is defined in 0 to 3, well defined. Otherwise the value is 0. So that can be written as 0 to 3 x by 6 plus k dx equal to 1. On simplification, you can find the value of k as 1 by 12. Now coming to mean, since the function is defined in 0 to 3, so mean equal to expectation of x equal to mu equal to integration from 0 to 3 x into f of x dx formula. X into f of x means x by 6 plus k. Simplify it and write down separately and then integrate the functional value. Substitute the upper limit minus lower limit. We'll get the mean value as 15 by 8. Now calculate the probability of x which lies between 1 and 2. So probability of 1 less than or equal to x less than or equal to 2 equal to integration from 1 to 2 f of x dx. So integration 1 to 2 h by 6 plus k value is 1 by 12 into dx. Integrate with respect to x. Integration of x is x square by 2. Integration of 1 is x. Within the limits 1 to. Take upper limit minus lower limit. Value is 1 by 3. Let's solve one more problem. The probability density function of a random variable capital X is f of x equal to sin h by 2 for 0 less than or equal to x less than or equal to pi, otherwise 0. We need to find the mean probability values and mode. So coming to the definition of mean equal to mu equal to expectation of x equal to integration from minus infinity to infinity x into f of x dx. We can rewrite this integration from minus infinity to 0 plus 0 to pi plus pi to infinity. First and third integral is 0 and we need to solve the second integral, that is integration from 0 to pi by 2 x sin x by 2 dx. Here you have two parts in integration, so apply integration by parts. Use highlight rule. First function is x, second function is sin x here. Integration by parts. Upper limit minus lower limit. The value of cos pi is minus 1. Sin pi 0, sin 0, 0. Cos 0, 1, 1 into 0, 0. After simplification, the value of mean is pi by 2. Now the probability of x which lies between 0 to pi by 2. So take the integration from 0 to pi by 2. F of x dx equal to 0 to pi by 2 sin x by 2 dx. 1 by 2 is constant and this is single function sin x. Integration of sin x minus cos x within the limit 0 to pi by 2. Substitute upper limit minus lower limit. So cos 90 minus cos 0. The result is 1 by 2. Mode. It is a value of x for which f of x is maximum. So here f dash x is 0 and f double dash x is negative. At that value. So we need to find that value. So we are taking its value as pi by 2. So if you observe f dash x is cos x by 2, f of x is sin x by 2. So f dash x is 0. And calculate f double dash x, that is minus sin x by 2. Sin 91, so minus 1 by 2, which is less than 0, negative value. So f dash x value is 0 and f double dash x is less than 0, negative value for x equal to pi by 2. So you can take that x value as mode here. So mode is pi by 2. Right, next problem. If x is a continuous random variable and y equal to ax plus b, then we have to prove expectation of y equal to a into expectation of x plus b, and the variance of y as a square into variance of x, where a comma b are constants. So these two are properties of mean and variance. Y equal to ax plus b, consider, take expectation on both sides. So expectation of y equal to expectation of ax plus b. So expectation of a function, formula minus infinity infinity x into f of x dx. So minus infinity infinity, in place of x we have ax plus b. So ax plus b into f of x dx. So integration minus infinity infinity ax plus b, we are writing as two terms. So first one, you can observe that a into the integration part is expectation of x. From the definition of expectation of x, you can write expectation of minus infinity infinity x f of x dx as expectation of x, plus b into that value is 1. Since integration from minus infinity infinity f of x dx total probability is 1, so that value is 1. So that is the first proof. Expectation of y equal to a into expectation of x plus b. Now to solve second one, so we are taking equation number 1 and 2. So now 1 minus 2. So that is y minus expectation of y on left hand side, right hand side. You have ax plus b minus a expectation of x minus b, b cancel. and squaring on both sides, and then we are taking expectation on both sides. So expectation of y minus expectation of y whole square, which is equal to a square into expectation of x minus expectation of x whole square. Left hand side, you can observe that the value is variance of y. Right hand side, a square into variance of x. So if x is a continuous random variable and y equal to ax plus b, then expectation of y equal to a into expectation of x plus b, and variance of y equal to a square into variance of x. So this is for today's class.